All right, so let's look at this. So we're going to do delivered. Sounds about right. All right, so derivatives of logarithmic function and exponential functions. So here, a derivative of any log is 1 over x ln of a. Your book, I think your book does, yes, your book completely shows you how to do it. It slowly works through each single step of how to do it with lots of log rules. For the sake of time, it's like, I don't think you guys care to watch me do a proof that you'll never do again. Just putting it out there. So we're just going to jump straight to it. So this, but notice here, if a is e, so 1 over x ln of e, well, ln of e, of course, is 1. And so this just becomes 1 over x. And so these technically are the same in my mind. So let's take some derivatives. So let's take log base 10 of this. All right, so in order to do this, so let's go ahead and do this. So f prime is equal to 1 over what's on the inside, so it'll be 2 plus sine of x multiplied by ln of 10. And then we need to, but hold on, so we're going to do a little bit of a chain rule here. So we're going to let this be u, so this be 1 over u ln of 10 times d, or times u prime. Okay, and so now I do this. Now I need to take the derivative, so of the inside. And the derivative of the inside here is 0 plus cosine. So it's just cosine of x. Does everyone understand why I have to use chain rule here? Any questions on where this cosine of x came from? Please let me know. I can re-explain it real quick in a different way that may be less confusing. No, everyone seems okay with it, at least so far. So f prime, and so this becomes cosine of x over 2 plus sine of x ln of 10. Okay. All right. Let's do this again. So here we're going to take this derivative. Here I'm going to change this to u, so it'd be 1 over u prime. And so here, y prime is equal to 1 over x cubed plus 1 times u prime. So this derivative here would be 3x squared plus 0. So if I simplify that out, I get 3x squared over x cubed plus 1. And that's it. All right, so next one. So here, you may differentiate this, you may show it in this form, and here, this means take the derivative, same thing as before. So here I have 1 over, we're going to let this equal to u, and so it'll be 1 over u prime, and so we'll have 1 over sine of x. Derivative of sine of x is cosine of x. Okay, and so this becomes cosine of x, and then here, so I have cosine of x over sine of x, and that's the same thing as cotangent of x. I mean, if you left it here, I'd be perfectly happy. Okay, so that's how we did that. I'll leave that here. Hopefully section 3.3 is fairly straightforward. I try to weight more of the homework on to 3.3 because that's what we're going to be using henceforward. Can we review example again? Sure, I can do one. I can do one again. Let me do example 1 again. I should have probably made example 1, example 3. So here, for example 1, so here, yeah, I'm just going, woohoo, I'm on the wrong layer. Of course I was. So here, I'm going to do log base 10 of u, f of u, f prime of u. And so here, if I took this derivative, it'd be log 10 of u prime. So the derivative of this with respect to u, and then the derivative of u. And so this with respect to u, well, u is 2 plus sine x. So it would be 2 plus sine of x. And then here, since it's log base something, it'll be ln of that something. So here I get ln of 10. And then I have to take my prime. So my derivative of this, well, the derivative of 2 is 0. And the derivative of sine is cosine. And then you just put it together. So here, I simplify my function of this and then take its derivative. And that'd be 1 over u, ln 10. Then I plug in what u was, 2 plus sine of x. But since I did my chain rule, I have to do my derivative of my what I replaced it with. And this, so u prime would be cosine of x. Okay. All right, let's go to the next page. All right, so here's the next thing. So derivative of a to the x is equal to a to the x ln of a, or e to the x is equal to e to the x. And so the derivative of e to the x is itself. It's actually the simplest derivative you take. It doesn't change at all. Therefore, and so we're going to use these rules. And so here, we're going to do this one. And so here we're going to do this right here. We're going to let u equal to tangent of x. Let's be very clear. And then u prime, so u prime, if u is tangent of x, u prime is secant squared of x. So here I'd have e to the u. So f prime is equal to e to the u prime, which is equal to, well, u is, in this case, was tangent of x, so e to the tangent of x. I spelled tax, not tangent of x. It is tax season, so if you haven't done your taxes, do so now. Times secant squared x. Or another way of doing it is leave this consistent and just take the derivative of whatever's up top and just drop it down. All right. I'm going to save number 5 for last. Because you take a log first and you do something called log. You take a log first and then differentiate it, and you can produce the answer. It's kind of weird. So let me show you how to do 6 next, and then we'll come back to 5. When I redo these notes, I'm going to switch the order. All right, so let's do this one. So here we have, so the derivative of e to the x. So let's just say this is f and this is g, right? So f is going to be e to the x, f prime is equal to e to the x, and then the derivative of this will just be -1, so this will be minus e to the x. G is equal to sine of 4x, so g prime is equal to 4 cosine 4x, because here take cosine of 4x, and then we take the derivative of the inside, which is 4, so that's our chain rule. All right, then from here, let's go ahead and so here, so this derivative would be f prime g plus g, or plus g f g prime. And so in our case, this will be equal to minus e to the x times sine of 4x plus e to the minus x. Oh, so sorry, this has a negative sign on it too. And then 4 cosine of x. And you can leave it like this. For me, you can certainly leave it like this. Your book will want you to pull out the e to the x just because it's a constant, it's everywhere. So here I'll have 4 cosine 4x minus sine of 4x. That's fine too. So here we're just using product rule. Okay. All right, so now let me explain how to differentiate. So some things, so here I have x e to the x. Well, x is my exponent, right? And so that just kind of ruins all this because it's not, a assumes it's some sort of constant, e assumes it's some sort of constant, but x is not. But here I want to differentiate x to the x raised to the x power. I'm like, well, that's weird, right? And so the trick here is I just take the log to both sides. So if this is true, this is still true. And then what we're going to do is we differentiate both sides. And so here, this becomes 1 over y prime. Do I know what y prime is? Well, y is some function. That's what I'm solving for. I want to find its derivative, right? And so we actually just leave the y prime here. And then here, this becomes square root of x over 1 over square root of x times ln of x. And here, because I can pull that out, and then when I take its derivative, hold on, let me put this in the right spot. I can simplify this because of my log rules as x ln of x. Then I can take its derivative. Hold on, how could mm. Thank you. Someone asked the question, why is e to the minus x derivative equal to... Something's bugging my nose. I'm gonna blow my nose real quick. Sorry, guys. Let me mute. Here we go. Someone asked this question in the chat real quick. It's because e to the x, it's because here it'd be e to the minus x times the derivative of minus x prime. So the derivative of minus x prime is -1. So this is equal to e to the minus x times the -1, which is equal to minus e to the x. All right. So let's look what we did here. So here, we implicitly differentiated this. So we have 1 over y, y prime equal. And then here, I'm going to do product rule for this, right? I'm going to do product rule. So here I'll have x. And so here I'll do product rule to differentiate this when I differentiate both sides, right? So here we're doing implicit differentiation. So we're just differentiating everything. So here, when I differentiate this, we're going to let f equal to square root of x. That means f inverse, or not f inverse, whoops, f prime is equal to 1/2 x to the minus 1/2 power. Or just to make our lives easier, I'll just write this as 1 over 2 times the square root of x. We're going to let g equal to ln of x. That means that g prime is equal to 1 over x. And so when I differentiate this, it'll be f prime. So here, let me write that clearly. Boop, 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 boop. F prime, which would be 1 over square root 2 times ln of x plus square root x over x. So square root x over x. All right, and then we just want to solve by y prime. Do I know what y is? Yeah, y is equal to this. So this is 1 over square root. Let me write this over on this side. So this is 1 over y prime, 1 over the square root of x raised to the x to the x. And so if we solve for y prime, we're just going to be multiplying both sides by x raised to the square root of x. So we have y prime is equal to x raised to the square root of x, 1 over 2x ln x plus x over x. Okay. And so to differentiate things using logarithmic differentiation, the whole thing here is you take the log to both sides, and that will clear out your exponent. So here, by clearing out this, I don't have an exponent here. I don't have a variable raised to a variable. And so then I can implicitly differentiate this side. So it becomes 1 over y prime. But I know what y is, so you can just plug it back in and you just solve for y prime. Okay. Can you see the last problem one more time? Here, I'll zoom out. All right, so that's the end of class. We're 2 minutes early. Hey. So I'll let you finish copying it down. Go ahead and work on these problems. This trick in number 5, you'll see a couple times. You'll get used to it. It ends up falling out. This side always ends up being the same. It always ends up being 1 over y prime. It always ends up being that. And so when you do this, it's always just y prime over y. And then you're just going to plug in whatever your y was. And so this would be y prime over x square root x. And then you just multiply it across. And so if let's pretend it was something, it would be like something, say it was like x raised to the x squared, right? Just something random. If I did this again, my y in this case will be this. And so it'd be y prime over x to the 3x squared, because it always ends up being this. It always ends up being this, equal to, and then I'd have 3x squared ln of x, because if I took the log of both sides, that's what I'd have, and then you just differentiate this mess, and then